everything is going smooth in the interview, and then interviewer hit you with that dreaded question: what is the architecture of your GenAI project in production? I mean, many people are not still into production grade application development in GenAI, and they feel overwhelming, and when they apply for interview or they're undergoing interview in GenAI, they feel underconfident while explaining their project. So don't worry about that, I have got you covered for this part. So let us see end-to-end RAG application with evaluation on AWS Cloud. And I mean, you can build anything like Agentic AI or MCP integration or any other new things you wanted to do here if you know this particular reference architecture. When we talk about RAG, like retrieval augmented generation, I know everybody knows that one, but I'm giving just brief intro. Retrieval augmented generation needed when LLM doesn't have information of like private knowledge, or where LLM is not trained with the data what you have it. That time you need to retrieve that data and augment with that context to LLM, and then LLM generate response. That's what retrieval augmented generation. And before retrieving, we need to store those data also into vector database. We will go through this architecture and then run the application, and then dissecting all those part one by one. I'll not go like depth of AWS cloud or any other things. We will have more session for that part. But when we talk about this like architecture, it has Streamlit UI. When user upload document, it goes through Amazon API gateway, that is basically your gatekeeper, like front door, and it store like it runs your Lambda, AWS Lambda, basically upload handler, and that is storing some metadata into DynamoDB, and then storing data into S3 bucket, data bucket, that is basically blob storage or document storage. And then this data bucket runs like your triggers as event your AWS Lambda then store, like it runs, it calls your embedding model and then create chunks, embedding model, embed it and store into PostgreSQL. I'm using AWS RDS PostgreSQL using pgvector as a extension, and with that we can use it as a like a vector database. So basically all this data is whatever document we are storing it, creating chunk and then embedding it, storing into this database. Later on when we do query, it again goes through the Amazon API gateway, and for both like upload document, query, it goes through Cognito, like your username, password, like token based authentication. It get authenticated, and when in case of query, it runs your AWS Lambda like query processor, and that we have all business logic to query, like it just embed your query, and then with that embedding query, it goes through your Postgres database and retrieve information chunks. With this retrieving chunks, we store like your query plus retrieve chunks goes through your Gemini LLM, and then it retrieves, I mean it gives you response, and then response is generated back and giving it back to the user. So this is how it is there. Like I'm just giving it like very high level overview. And it has all like AWS component. You see AWS like Amazon VPC, Virtual Private Cloud, all these lambdas are there, and it has private subnet and public subnet and VPC gateway endpoint. We'll see this thing in a few minutes. So when we run this application, I'm running it here at my local system, this UI. Rest all are in AWS Cloud. When I run this one, it is running here in 8501 port, and I need to register my user first. So what I'll do, my email, and I'm registering this one. So user is registered, and when it is registered, it will be sending one verification code to my email like Gmail address. So I'll go there and see this code. So this is right now coming from AWS Cloud using AWS Cognito. I'm verifying it. So user is verified, and I'll go and log in, password, and I'm into the system. I'm using Gemini model because it has free tier and you can use it very cost effective, like there is no cost involved in this part. So I'm using Gemini 2.0 Flash right now. I'll upload document. I uploaded one document PDF file here, and it will give certain details like what all things are there, and upload document. This is what it is done when we run this particular part like upload document. So we can see it is success now, and this is the document I uploaded. So I'll go and copy anything like this thing and query. So important here is it has a RAG evaluation setting. I am using RAG evaluation with the Gemini model itself and with all this like your relevancy and other stuff. So I'm just enabling this one, and if you have ground truth of your query, you can also provide that one. Like if you select this one, it will give you another box here like text box, you can give it so that you can check with your ground truth. So I'm not giving that part. I'll copy this query and submit this query. So we can see result, and it get all this like document details, like all relevancy, also like relevancy scores, and it has evaluation score also, like answer is relevancy, faithfulness, and apart from that, like if you give it context like your ground truth also, you can generate context precision also. So this is in nutshell a complete application. That's what it is built. It is having like token management also, like token expiring in 1 hour, and it is managed through AWS Cognito. So let us quickly go to the code part and understand all these things like in high level, what all things are there, and later in all the other session we can see it more details, like go depth wise all those part. But with this you will able to kickstart and understand like how this application runs in production, and you can explain this part also. So I have this RAG app on AWS code, and this is here in my GitHub repo. How you can start it quickly, like I'll first go the fast way. Like I have one demo account of GitHub, and see, first search my repo. So this is my repo Genie in code bottle, and I can see RAG app on AWS. I'll go here and fork it. This is the quickest way to start this part, like running it without cloning it and making it your own way. So you can copy all the branches. So I'll just untick this one and RAG app on AWS, create fork. I have this code with my repo, like this is my demo account, Rashivasa2. So here I have this like RAG app on AWS that is there in my Genie in code bottle account. And what I need to do here, go to action and just do it. Like I understand my workflow, go ahead and enable them. So you can see two things here, like manual AWS cleanup and Terraform AWS deployment. These two things should appear here. Now what I'll do it, like I'll go to RAG app on AWS and copy it and clone it. Like you may clone it like anyway. I am using git bash here. Git clone, you can download git bash from your internet, and you can have this one git bash if you don't have it, or any other way you want it, do it. So git clone, but you should have git command in your local system, and I am cloning here in my system. So I cloned this one and I'm running it main branch, and you can use develop branch. You can check out that branch like git checkout develop, but I'm running in main branch because it may need it in SonarCloud as a like a main branch. I'll show why it is needed main branch here. Now one important part, like few things we need, like GitHub Gemini account, like Gemini API key, SonarCloud optional. Also it is easy for you to integrate. This all are free. AWS account if you don't have it, Python, and Terraform, HashiCorp Terraform. So you don't need to know what is this all things, like how it works, like other stuff, syntax, other things. Like it is all things are covered in my application, and you can go to this one once and you can deploy and run it your application, and later on understand in depth one by one. So we have this RAG app on AWS with my GitHub repo. I forked that one. I checked out also in my local system, and action also, like it is enabled. I can see this two action like git workflow here. We'll go setting part. So setting is important to set your AWS account, like your keys, your secret keys, and your other stuffs like your Sonar. If you need Sonar, then it is needed there. So I'll go here and go to secrets and variable action and new repository secret. So it is here, secrets and variable action, and copied here, from where you will get AWS access key ID. So for that you need to have first AWS account. If you don't have it, create it first. AWS account is easy to do this one, and I am running right now, like I'll sign out here. I am running as a root. I suggest go through root because it's not going in production or anything, like it is fine. You can do through root account because it's easy for you to see all these things without having like any access issue. So when you create your account, if you don't have it, after that you see this screen like for login screen where you have a IAM user and one root user. So first time you create, you will have a root user. You use that root user, like I am using this root user. It is not recommended in production or any other places, like when you're in company going through root user, because it is having full privilege. I'm running it here because you are doing experimentation. You should not run through some access issue or some other stuff. So giving it password, sign in, I have multi-factor authentication setup here. So it is asking because of that. You may set up also that one when you create your AWS account. And when you see at the top, there's one security credentials. You click on that. And you will see this console. In this console, you can create access key. When you create access key, it will be saying like root user. That's fine. It is because you're working with root, so it will warn you. And I mean, I got this access key. What I'll do, I'll copy this one. Same way you will get it. So copy this one, AWS access key ID, same name, and add secret. So when you are storing this information here, it is stored as a secret. Nobody can access this one. Only you can see this one, and it is not accessible to anyone. It can't be hacked and other stuff. So one part AWS access key ID. Now I'll go with this one. I'll copy. So added secret. So your AWS setup is completed. Now there's one thing like SonarCloud I used as a quality gate where you can see your all this code like your bugs or anything like your test cases and coverage and other stuffs like just it's like quality gate. You can create your SonarCloud account freely. It doesn't have any cost involved. Same way like when you go with the AWS cloud, it has free tier for 1 year and it is sufficient. Like most of things will be done with the serverless and free tier. You don't need to I mean burn any cost with the AWS cloud. Same way SonarCube cloud also. So recommended way to go through GitHub, what GitHub account you have it, because it will directly access your all this repo and you can create I mean all this configuration part here. So I have this already GitHub login here, so that's why it is asking it like authorize. So I'll authorize it. I can see information here. What I'll do, I'll import an organization. Import an organization means like from this particular GitHub, like your GitHub account, everything will be imported here. So I'll go with all repository. There are many repository like this is dummy account, but you can select from there later on and confirm it like what you wanted. So it will ask for your password. Password means your GitHub password. So whatever name is there, you want to give it some name, you can give it. Otherwise, take it as a default. So there are certain plans here. So you'll go with free. When you go with free, only main branch can be accessed here. So it can be, I mean, all like your SonarCube will run against that main branch only. You can't run against your develop branch or any other feature branch. So I'll go with the free one because I have main branch and I'll work with that one because it will be easy for you. Otherwise, if you go with like your another one, start free trial with the $32 month, it will give you around 17 to 18 days free trial. It will ask credit card and other stuff. So if you don't want that one, go with the free plan. I'll select this one and create organization. Whatever project I have in my GitHub account, I can see here because I selected all this part. I'll search what was their RAG app on AWS setup. This is part your quality gate in your application, how you integrate that one, and I suggest go to this one because if you explain your project where you have quality gate and how all this your bug tracking other things are done, it will be easy for you to I mean convince the interviewer or anyone, like it gives you a plus point. So here I'll selected this one, setup. I'll select previous version, like anything happened previously, if any changes happen, based on that I mean it will run and it will give you all this like dashboard and other stuff. With this previous version, create the project and I can see this particular console. So now I need to integrate this SonarCloud, I mean SonarCube with our application. Since you already have these things and you already set up your AWS account, like secret key and access key, you need to create one repository token as a Sonar token. And if you come here in your SonarCube, SonarCloud with GitHub Actions, because we are integrating this with GitHub Action. So here if I'll come, Sonar token is already there. I'll copy this one, paste it, add secret. So I have all these things, like I have AWS related information like all tokens and Sonar token. So after our initial setup, we need to understand code part. So whenever we develop any application in production, we have one repository and there will be certain branches like I have here main branch and develop branch. Main branch is basically goes into production, like that there will be staging branch that will go into staging pre-production, and same way develop branch goes into develop, I mean development environment. So there are three environment right now here. Production for main branch, your staging for staging branch right now it doesn't have it. You can create develop for development stuff like development environment. We don't change anything directly into main and develop branch. What we do it, we create branch against, like this is git flow. I mean, there are trunk based development also, like major company, a lot of thing company like Google, Meta, and many company uses trunk based, directly pushing things into main branch. There will be ephemeral like temporary branches running as like where development things will be done. It will merge into main branch and then it works like this trunk based. But this is git flow where we have more control when team is quite new and they will be released. There are certain release process that doesn't runs every day, maybe weekly or maybe monthly. Their development like production release process is there. So in that case we have one main develop and staging branch. Against develop branch, what we do it, we create one feature branch. Suppose as a developer you want to work it, and after that you check out like suppose I'll do it here. I mean, I'll create some branch here. So it will be against develop branch, create new branch. Now whatever I'll do here, I'll work on this feature test branch. I need to check out, because right now if you clone it, it will be coming as a master branch to you. So I need to get check out and that particular branch, and you will be working on that part. But I'm not going to that part. I'm directly working in main branch just to show you, because there is certain constraint when you are using SonarCloud as a free version. There you can use only main branch. You can't give it like develop branch and other feature branch. If you are paying it, then that time you use it. So that's why I just checked out didn't check out any other branch, directly working on main branch. Let us go through all this code, I mean, as high level, so that you understand what all things are there. I'll cover these things later on, I mean, another session more depth, but maybe understand as a high level and try to make changes here, adopt it as per your requirement, and see how you can progress with this particular reference architecture. So we have a GitHub workflow one folder where we can see deploy.yaml, like it is having Terraform AWS deployment, and same way like cleaning up all resources once you are done. So we are using Terraform to provision AWS resources. It can be used for Azure and GCP, anywhere. Terraform is very famous for provisioning all this cloud. So it is using SCL like HashiCorp corporation language to do this all this like provisioning part. And you can see this all code in environment folder. This having three environment: dev, prod, and staging. Dev is matched with your develop branch, and prod is matched with main branch. Since we are cloned as a like main branch, so we will be changing anything in prod branch. Same way staging is I mean mapped with your staging branch. So this is one environment part. Will come back here to show what all things are there. Same way workflow also. Module is having subfolders of API authentication, all these AWS resources what you see it here. Like all these things are getting deployed using HashiCorp corporation, I mean SCL. And here all these scripts are written. For every subfolder you can see one main.tf, output, and variables. Like this all scripts are written to provision it the way we want it. Okay, so you don't need to change things here. We can have more session of this SCL part to understand it better, because Terraform itself is having one more skill to understand. I mean, but it will work for you if you want to deploy it. I mean, you don't need to know in detail what all things are there. This is one thing. And same like one RAG UI, this is Streamlit UI is created for running this particular AWS resources at your local, so that you can do all this whatever we seen it earlier, querying it, uploading it, other stuff. This is one RAG UI, this is running at local. Script is basically we are using cleanup script. Once you are done through this GitHub action like manual cleanup, this manual cleanup we are running it like we are removing everything so that you don't incur any cost by mistake. Same way import resources is like if anything you are importing it and if you already have certain resources same name, you can import it using this import resources, so that it will not be duplicated. It will not show error like existing resources. Network diagnostics we can see later on. It is just if you have any issue, just I created because I had a lot of issues connecting with resources. That's why I use this network diagnostic shell script. This is all shell script. One SRC folder is where we have all this Lambda code, like our backend code. One auth handler is having auth handler related to Cognito, AWS Cognito, because it connect through this AWS. If you see here, your when we connect, I mean when we log in it or after login, anything you do it can connect through AWS Cognito. It uses token based authentication, and it is very tightly integrated with Amazon API gateway, so it works very well. So all these codes are written here. And again, Lambda part, I'm not sure you worked or not, but we can have further session to understand it better, because it will stretch this session if we'll go detail part on Lambda part. But I'll give you overview for any Lambda, whatever you see it here. This Auth handler, DB init, document processor. Like document processor, you see here document processor is used as a event trigger. When we upload document into upload handler, it goes through bucket and then your document processor is initiated. So whatever code we have seen it here, it is a starting point. Like their main function is def handler. You can give any other name, but it should have event and context, these two parameter. With this it understand. So I'm using handler. So accordingly, if you'll go to the modules and compute and main.tf, like if you see this resource is assigned like this, your function name, this is basically local dot handler name. If I'll go up, this is upload handler. So this is our function name. And I mean, you don't need to change anything here. And in that upload handler dot handler, if you change function name to something else, you need to change here also. And runtime 3.11 and environment variable we have given it. So if I come here in Lambda and see here OS environment, this all environment is given in your modules compute main.tf. If you can see the same name, Lambda name is there, auth handler. In that it will be given as a like your environment variable. That's what we are accessing it. Some motor libraries to connect to AWS services, and all this code are related to that one. So whatever Lambda code you see here, this all things are here. Auth handler, DB init is used once when we deploy as a pipeline to create database and to initialize database, to make it like install pgvector extension to make it as a vector database. Like PostgreSQL is not like your vector database, but with the pgvector extension it can become vector database. That's what we using it here. So DB init is used for that one. Query processor is used here. This is where all this code is, all this your backend code is given in SRC part, and all your Terraform code is given in modules part. When we deploy this application through GitHub pipeline, like if I'll come here and see this GitHub pipeline, action pipeline, it has this job, determine environment, build Lambda, and deployment, like your Terraform plan, and apply means deploy resources, integration test. It runs GitHub workflow like deploy YAML. If you see here, on push to branches main develop staging. Since we are using main right now, if you push anything here, if you change it, commit it, and we can see this pipeline will be running. We'll see this one. If we create any pull request, since we are using git flow where we are supposed to work as a feature branch and then merge into, create pull request against develop branch, main branch, and after review we merge it, then also it will run. In case if we want to do manual also, we can run manual also. And if you see jobs, determine environment, like that, if you runs on one runner, basically one container, every job whatever you see here, every job runs on different containers, different 1-2 containers. I'm using it here. So basically it is GitHub runner. It is freely available to us. All things runs separately in isolation, and we can forward output of one thing into another job also. That's what you may see here, output of this thing. And now we can use it, like if you see like determine environment is there, what environment we are using it, and in under code quality like sonar quality, we need determine environment. So with this we can get the output of that previous job and use it. And this all GitHub Actions are using basically our Terraform code, and from where you see this environment, dev, prod, and staging. For us, suppose we are using main branch directly, we need to come here, this main.tf, it will be using it, and this all things will be using whatever resources there in modules like Terraform scripts. So basically this is container, this is using like modelize modules, whatever we modelize this thing, and later on this is getting used into workflow. Important part here is for you, like you don't need to understand all this part. I'm just giving you brief because there are so many things to understand and you will be overwhelmed. Important for a part is here, change your project name to something else, because if you keep the same name, I may be using this one and I have created one S3 bucket with the same name. Now with suppose RAG dash app dash with environment prod or dev. It is already here with me. You will get error, so give it some unique name with your name or some other name you want to give it, so that it will be unique for you, and keep it this thing same. Change this GitHub repo name to, like I am using Rasivastav 2 right now. It was basically genie in code bottle. When you do first time clone, change it to your prefix. Like right now I have this prefix here, so I use this one. And alert email also change it, because it will be used for monitoring SNS. Other stuffs will be coming, other it will coming to me. So this is one important Terraform TF variables that need to change, and this is what it get used into workflow to deploy all resources where it's supposed to go. Now I did all these changes, and I can show it like how pipeline runs. But before going into that part, we need to know some test cases also, and like one simple integration test. If you want to write it, okay, that's fine. I just given it as a one job here. Integration, everything is done. Just check simple like health check. So with that, if it is successful, it is successful, otherwise it will show as a fail. This integration test is written. Same way unit test case is written for every Lambda. Maybe one, I think one auth handler is not written, but everything is written. Why it is needed? When we run this code in this pipeline, there is one SonarCloud. This is optional step. Even if it fails, everything will run. I made it optional. Okay, I can come here and show it. Deploy YAML. So if I'll come here, code quality, and this code quality. So code quality is basically SonarCloud. Name is SonarCloud, and continue on error true. Because if you don't want to run this SonarCloud, that is fine. If you don't want to give Sonar token, that is fine. Even if it's free, I say like use it so that you know how enterprise Git application runs. I mean, not everybody uses, but most of the application I use, we have some quality Git to how this type of setup, and it has all the setup. Like if you see talks.ini sonar property, where you need to change things as per your requirement. Like if I'll go here in Sonar and see here, you need to click this others and see here. Just copy whatever you have it and paste it. Same will go there. Organization, it also same. So you need to change this one to run it at your system. Otherwise it will take my genie in code bottle and it will throw error. If you created SonarCloud account and created organization, in that you use this RAG app on AWS to integrate with your pipeline, it will be showing it in analysis method. Go to GitHub Action, get all this information like others, get other information, copy it, token you already have it. So this is what it is getting changed. Other stuff, keep it as it is, whatever things are here, because it will be using this to this analyze all your code. And talks.ini is required to do all your py testing, like your unit testing. Maybe it will be too much to show it here right now, so I'll keep it separate session for this part. Keep it as it is, whatever is here, just change in this part. With this it will be integrated, and this requirement and all things, it will be same. When we run this deploy YAML, it runs all this pipeline, all this code you see it, this GitHub Action code is given here. It uses different your Terraform modules, whatever is given in environment, and uses this one. You see here working directory environments, and the way determine environment, whether it is dev, staging or production, it will come here. Like suppose in our case it will go to prod. In this prod, it will be running this Terraform init, then it will be running this main.tf, and accordingly it will run. So I'll just show here one workflow how it runs. You push any code changes, GitHub repository, like right now we did a lot of things, we'll see this one. And then after that, this GitHub Actions, what it does, it trigger workflow like deploy.yaml. It determine environment, whether it is dev, prod or staging, and based on this, like what branch it is running it. Suppose it is main, it will be running in prod environment, and it does quality test, it execute code, Solar scan, It install dependencies, it package all this Lambda folders, like whatever we see in here as src, it will package all this stuff here. And after that, Terraform init. After Terraform plan, what is Terraform init? Means initialization part. Terraform plan means before deploying anything, it should make sure like there should not be any error. So Terraform plan is for that one only. And then after that, Terraform apply, where it does everything, like it create VPC, it creates subnets and all the security groups, whatever things needed, and then upload your Lambda folder, and then execute integration test and verify, and then it is done everything. If it fails, then it throws something error, and you can see code here. Basically whatever you see it here, all this pipeline runs through this process. This is already there in the documentation, like my readme file, you can go through and understand better way, but this is how it runs. And Sonar property and other stuff, you need to change it same way like your environment, with different environment, your Terraform TFS, change it, otherwise it will throw error. But before running this one, there's one issue. I mean, it's not easy to build application in production. You can see there are a lot of things out there, many things are running here and there, and when you work in production environment, there will be many things, many blockers to access resources, many security things will be there. Here if you see Amazon API gateway, as a default timeout is 30 seconds, and 30 seconds is very less for GenAI application. Like when we are doing certain things like querying it, it may take 1 minute sometimes because of large information coming. I mean, it should not take, but it may take large information. I mean, it may take more time, so it may time out. 30 seconds is default API gateway. But here's thing, like you can increase this default time to your AWS account. Like if you go here, quota, I already gave this information in this readme file. You see here, it is already given. So you need to come here, like I am using US East 1. US East 1 is basically United States North Virginia, and service is API gateway. Quota is basically maximum integration timeout in millisecond. So by default this is 29,000 second. I mean 29,000 millisecond, it is 29 second, but it is counted as 30 second. I gave it 1,50,000. Basically 2.5 minutes. You need to give same information because this is given here in configuration. If I'll go here and timeout millisecond, it is 1,50,000 millisecond. 2.5 minutes. 2.5 minutes is sufficient for our use case. You can increase it more if it is not working. Like keep it 3 lakh something. Same way, if you are keeping it 3 lakh here, you need to come here and request for quota increase. And if you add it, it will be immediately, like if you don't give it more quota like 15 minutes or 20 minutes, it will be immediately approved. So with that, you don't see any error. Right now I already give this thing, like I already have as a 15,000 as a quota increase, so I don't need to give it here. But if you are giving it, if you are running it first time, when you have AWS account already given in this documentation, click on this US East 1, add like this all stuff, add it, and it get approved. So you don't get any error when provisioning your AWS resources. This is one thing you need to do it separately out of like your provisioning, automatic provisioning through pipeline. And there's one other thing, I'll just show it, like your secret and other stuff. After this, what I'll do, it is already there, I'll give it git add whatever changes I did here. Right now I did a lot of changes, like giving it my project name and other stuff. Project name I kept it same because I'm just using it. You need to change it. And Sonar project properties, because this is how it is configured. Git commit. So I'll just give it initial commit. So code is pushed to main branch. We can check that. I'll come here and see there's some issue in this code. So there is some issue with my this account where I get certain account related issue, maybe some payment issue. But GitHub Action has around 2000 minutes free for you per month, so you can use that one as a deployment and all this thing without any cost. and it's working fine for me in another account. So I'll switch to that account for further exploration part and just showing it what is happening there. This is my repo in Genie in code bottle account, and I will show all those things, running it, pipeline, everything from here only. There's certain changes I did and I'll deploy it right now. I'll just commit that changes. And see our GitHub action pipeline running at portal, like GitHub portal. So I'll just come here and see in action. So this particular repo is running in develop branch right now. I checked out develop branch and just pushing it in develop branch, and then after that merging into main branch. My earlier repo was running on main branch directly, where I forked and directly running it. Since that was having issues, so I'll continue from here, and let us see this. So this is started, and you can see all this job, like what it's doing it, like it has all steps. In that steps you can see what happened there. So it is using environment dev because I am running through develop branch. I can go back and see other jobs, like SonarCube is successful. I can go and see, like you can see here in deploy what all the steps are there in particular job, what all the steps are there. So I'm in Sonar Cube, I'm running this many steps, and if you see post SonarCube scan, maybe SonarCube scan, this all get completed. And if I'll access this dashboard, I can see it is passed. And Terraform plan is also passed right now. It is deploying all this stuff in AWS cloud. We can see all these things are running. So after this Terraform apply, it will be doing it like running RDS instance to check it, check up RDS instance whether it is running it or not. Then invoking it database, just to database init Lambda, so that all this thing initial database setup is completed. And after that everything is done, integration test will run, and whether it will be passed or not, according to that we will see. And when SonarCube is passed, we can go to SonarCloud and see our app, like RAG app on AWS, and it is having like all this, like security, reliability, maintainability, hotspot reviewed, and code coverage, every stuff. Any duplication part is there. Since new code doesn't have any changes, it is having like previously whatever things are there to get continued. So let us see RAG UI till time this get deployed to AWS cloud, all this infra part. So we have RAG UI, and RAG UI we have this readme file. You can go to RAG app on AWS in that RAG UI, and in that readme file has some application flow diagram, like authentication flow. If you see, I gave you first overview of how it works, like user goes through Streamlit and API gateway, then with the AWS Cognito having it like security token, and then using Lambdas to do your query and upload part. It has all this sequence diagram in this readme file. In case of authentication flow, if you enter email and password, it posts, and then it goes to authentication handler Lambda, it goes to Cognito and return the credentials and initiate authentication results. As token is given to application, where it has 1 hour of expiry time, and then accordingly later on anything you do at your UI, like query, upload, it will work with that token, and any authentication will happen with through that token only. And it has like a flow of other stuffs, like verification flow. When we do first time, when we do first time registration, what happened, when we do first time verification, what happened, and token refresh, if in case of token refresh, what happened. All these flows are given here properly, like you can understand very well when you go through this readme file. Same way for different like doc upload flow. And if you see here, it's important flow, because when you are sending it, like when you're calling Streamlit UI using your registration, like your registered user and password, it uses that token and durability token. So with that, it initiate upload handler, like invoke Lambda handler through API gateway, and then again S3 and DynamoDB PostgreSQL operation. It does also certain things, it stores there. And it uses secret managers. Secret managers is basically to access your token, certain secrets like database credentials, Gemini API keys also. In case of upload handler, there is no Gemini API key, it is database credentials it is getting used. So all these flows are there. I mean, you can go through and understand. It's very well documented sequence diagram, and you can easily understand this part. Now we can see this deployment part is completed. This all checks are started, and we can see this all things are happening also. And invoke database init Lambda also done here, and it is showing 200. And everything is completed. I think I can go back and see, refresh. It is doing integration test. Deployment is completed, and integration test is also completed. Now we can go and verify if you want to see these things. So let me go to S3 part. That is our bucket. So it is having like RAG app, because I am running with develop branch, so it is deploying dev environment, RAG app dev documents, RAG app dev Lambda code, RAG app Terraform state is basically keeping it state, so that next time you deploy it will keep that same state. It will not recreate resources, it will use the resources whatever things are there. If something is getting changed, it will verify and it will throw error also. So this all things are created. We can see Lambda. All these lambdas are there, and we can see VPC. That is interesting part. This VPC is right now also created, and you can see the flow. Like if you see public subnet, this public subnet. So public subnet is connected through your network gateway, like internet gateway. Same way your private subnet is having like your NAT gateway, and there is some DynamoDB and S3 endpoint, like VPC endpoint. So we'll go through this part. I'll just show you. If you see in this application, I mean this part, this architecture, all this lambdas are right now in Amazon VPC, and this is how it is. Like all this, everything is right now. Even PostgreSQL also is in the VPC. Same way, your secret manager also in the VPC. And important thing is, wherever database is getting connected through Lambda, it will be in private subnet. So I'll have next session where I'll just explain what all things are there. I give certain things here to make things secure, to have it like a secure connection, so that anything, if you are like, we are connecting to Gemini API and Gemini embedding model that is sitting outside of network, like it is in internet. When you are connecting to internet, nothing should go unwanted, like any unwanted thing goes to internet, or anything should not come to you also, like there should not be security leakage. So for that, all this VPC part all this configured, and it is routed using proper like public subnet and private subnet. Wherever you are connecting to Lambda, where it is not internally connected to database, it is having public subnet, basically your Auth Lambda, your upload handler, and anything like your query and document processor that is connecting to databases, storing it, all this information, it is connecting using private subnet. So after this all deployment happened, one important thing we need to do it, like first thing we did earlier, service quota increase 1,50,000 for Amazon API gateway, so that it will have 2.5 instead of having 30-second. Another important thing is secret manager. So what happened, secret manager for database, it is automatically created. For Gemini, we need to create through Gemini Studio. So I'll have it. If you don't have, you need to go Gemini Studio AI and get API key, create API key. If you are doing first time, it will create project also, it will give to you. If not, you can select your project if it is already there, and you will get the API key. Now copy that API key. In my case, like I already have it, so I'll copy it here. And if you see RAG app dev, because it is in dev environment, Gemini API key, click on that. In this secret manager, go here, retrieve secret value, edit, and instead of this placeholder, copy paste it and save it. So with that, all this configuration and deployment part is completed. So let me summarize it for you, so that it is easy for you to understand. I know it's overwhelming to understand a lot of stuff here. So what we did, we forked a repo like Genin code bottle RAG app on AWS and in your account. After that, enabled actions. When you click on actions, you will get that enable options. You will enable it, so you'll start seeing this two workflow here. After that, setting security secret and variable action and repository secrets. So for that you need AWS account. So you created AWS account. In that security credentials you have it like security token and ID, and after that like Sonar token. If you have SonarCloud, if you want to enable it, I suggest it you go through that one. Create a SonarCloud account using GitHub and import your project. With that import, we already seen how to go about that one, like understand what we can do there, like creating a token and Sonar token, and then having it like your this Sonar project key and Sonar organizer. So you can go directly here and see it like analysis through analysis method with GitHub action. See the Sonar token, copy it, and other stuff like in this your Sonar project key and Sonar organization. You can copy it like by clicking on this others, copy this one and paste it, so that your integration is completed. And Sonar token you can provide it here again, repository secret. And after that you clone this repo at your system and change it, like any changes you want to do it, and run it. And after commit it. After committing, you will start seeing, like suppose you are running in main branch, you will start seeing it code running it here, like your pipeline running here, and you can verify if anything is getting failed here. So important thing, if you're running in main branch, you will be running here as a like prod, and you need to change a certain thing in this particular repo, specifically environment. If you running in main branch, so prod Terraform, change project name because it should be unique project name, otherwise it will conflict with S3 bucket. Change your GitHub repo, what you have it, and change alert mail. Same way change it for a dev and everyone, so that it will not conflict. And Sonar project properties, we already seen it. And this is how it will like you will not see any issue. And when you run it, if everything gets success, you have it like all resources, like all AWS resources deployed here. You need to change your secret manager of your RAG app Gemini API key based on your environment. Like if you are running in main branch, prod environment, RAG app prod, whatever name you have given as a project name. So this Gemini API key you can come retrieve and edit, give it your secret key value, and after that you can come to RAG UI. Like I'll go to RAG UI and just create you can, if you have UV you can directly create it, but I'll go with raw way. Python name, I'm creating what virtual environment in this RAG UI, so that I can run this Streamlit UI. Let it create. Can do when scripts activate. It is activated right now. You can install, if you have UV you can directly create UV when it will create directly all this thing, and you need to activate. But UV is faster to install library, so that's why I'm running it. Pip install. You can directly give it without UV also, it will install. If you don't have UV install, you can do pip install UV, it will install UV. And one more important thing, dot environment. I have dot environment example. If you're running it locally, if you have dot environment, change it dot environment example to dot environment, and in that give API endpoint Cognito client ID, from where in this pipeline after success you can see UV environment variables. So I'll download this one and extract that file, edit it and copy. Like this is API endpoint, give it same way Cognito. This is important, if you don't give it, it will not run, your UI will not run. So now you can do Streamlit, and make sure it should be running 8501 port localhost, otherwise you need to change according to that in your infra part also. So we can see this UI, and we can follow same thing what I did earlier, like when I started video. We can register with email, and then after that register you can verify it, and then log in it, upload document, and then query it accordingly. So after everything is completed, like you tested, experimented, I suggest to clean up all your resources so that you don't incur any unnecessary charges. For that, in Actions you can see manual AWS cleanup. One pipeline is there. You can click on that, run workflow. You can give it, like suppose you are using branch main, so you'll keep it as a branch main, and environment like prod, so give it prod. For me it is develop branch, so what I'll do, I'll give it develop, and dev, and run workflow. It will remove like all the resources. You can see it, like refresh it here, and you can see all this cleanup stuff started. So it will take around 30 minutes. Leave it like that, and once it is green after half an hour, just check it. It means everything is removed from your AWS resources, so you'll not incur any charges. So I suggest, like after doing all this experimentation, go through this one and run this manual AWS cleanup. Thank you for watching. I know it's not easy to digest all things, like it's overwhelming, lot of information, and for me also it's not easy because of many information need to be shared. But I'll try to have more session later on. I mean, if you have any issue, you can comment. I'll try to resolve that one, and maybe sometimes we'll have live session to just run this thing so that you can experiment it live environment itself, like at the live video itself.